Welcome to this video. Let's cut to the chase and let's finish this 1973 AP Calc BC multiple choice exam. Okay, we left off on number 28. If the substitution square root x is sine y is made in the integrand of integral from 0 to half square root x over square root 1 minus x dx, the resulting integral is what? Okay, so here's our integral. Okay, so ignore that first. They ask us to substitute square root x is sine y. Okay, so one technique is you could find dx from this line. It'll be 1 over 2 root x dx is cosine y. Sometimes it's easier to square both sides to get rid of that square root. So it'll be x is sine squared y. Okay, and we jump here to find dx. So dx would just be 2 sine y cosine y divided, we need the chain rule. So we first do the power rule on sine y quantity squared. Okay, so that's 2 sine y, and then times the root of sine, which is cosine, okay? Why do we want to do it like this? Well, it's easier. It looks nicer in this way than 1 over 2 root x times dx on this left-hand side, okay? That will make our substitution look nicer. And also we want to do that because, well, we need to substitute square root 1 minus x also. So we can do that simply by doing 1 minus x. So we do 1 minus on each side. Or add 1 to each side and then negate this. So one more time, we times negative 1 on both sides here. And then we add 1. So it becomes 1 minus x is 1 minus sine squared y. Okay, we want to do this because, well, we can simplify this right-hand side to cosine squared y by the Pythagorean identity. And then we square root both sides, so square root of 1 minus x is cosine y. So now we have everything x to the limits in the integrand in terms of y. Because square root x, they give us the definition as sine y. We found what square root of 1 minus x is, that's cosine y. dx we found as 2 sine y cosine y dy. Okay, so we plugged all those in. Limits of integration, we can plug into here or here, doesn't matter, it's the same definition. When x is 0, we can plug in here. Sine y is 0, so y is 0. When x is half, then sine y is 1 over root 2. That's when y is pi over 4. Okay, so the limits are 0 to pi over 4. Here we can cancel this cosine with this cosine. So I can even do it. So we're left with 2 sine squared y dy. Okay, and that's this answer right here. 28 is E. Okay. Let me pull up the solution manual just in case with a key. Give me 1 second. This one was 28. Oh, sorry, I chose the wrong answer. I did the right work, it's C, sorry. I chose the wrong limit of integration, okay? Sorry. Yeah, C. So all the work was that I just chose the wrong answer. Sorry about that. Okay. If y double prime is equal to 2y prime, and if y is equal to y prime, which is equal to e when x is 0, then when x is 1, y is what? This. I'm not sure if you're able to solve this in what they teach in BC now. I know how to solve it though, so I just did it. Here we can just write it as a characteristic equation again. So we move everything to one side and set it equal to 0. Okay, so we subtract 2y prime. Okay, so we can get the characteristic equation r squared minus 2r is equal to 0. We factor r minus 2 is equal to 0. So our solutions are r is 0 and r is 2. So our general solution will be c1 e to the 0x, which is 1. So c1 plus c2 e to the 2x, okay? So we need to now use our two initial conditions. They give us that y is equal to y prime, which is equal to e when x is 0. So y is 0 is e. Y prime is 0 is also equal to e. Okay, so we can differentiate our general solution of y. Y prime would be c2 times 2 times e to 2x. This would go away when we differentiate, right? This is just a constant. So here we're just left with 2c2 e to 2x. So let's use the initial conditions. Y of 0 is c1 plus c2. When we plug in x as 0, this would turn to 1, is equal to e. And then y prime of 0 is also equal to e, and that's when we plug in 0 here, that's just equal to 2c2. So c2 we could easily solve as e over 2. Since c2 is e over 2, c1 plus c2 is e, so c1 is also e over 2. So y is e over 2 plus e over 2, e to 2x. Okay, and we're interested in y of 1, because that's what they ask us. What x is 1, y is equal to what? So y of 1 is, we just plug in x as 1, so it's e over 2 plus e over 2 times e squared, or e cubed plus e over 2. E cubed plus e over 2, that looks like A. Let me double check, and I hope I didn't pick the wrong one again. Okay, good. Moving on, this one I did into the AB exam. You just divide through by the x squared. This is easy, just power rule. If f of x is ln of ln x, f prime of x is, this is simple chain rule. It's going outside in. Derivative of ln is 1 over the argument ln x times derivative of the inside. What's the derivative of ln x? That's just 1 over x. Okay, so 31 is e, as simple as that. If y is x ln to the ln x power, y prime is equal to what? Here we need logarithmic differentiation. I guess I did not do it beforehand. This is easy though. Okay, so I feel like I maybe have done this before, but let me just do it again. It's not hard. Okay, so we need to, because it's some function of x to some function of x power, we need to use logarithmic differentiation. We can't just do the power rule here. So we log both sides, so ln y is ln of x to the ln x. Properties of logs, we can pull the exponent out in front. Okay. So ln x times ln x, or you can even rewrite it as ln x quantity squared. Okay, so 1 over y, we implicitly differentiate dy dx. So we differentiate ln y, that's 1 over y divided by dx. Differentiate this, that'll be 2 ln x times 1 over x. That's the chain rule again. Okay, so dy dx is equal to, we move this y to this side, it'll be 2 ln x over x times y. What is y? Well, y is just x ln x. So we need a 2 ln x times x to the ln x over x. So 32 looks like it's C. That's correct. Okay, as simple as that. Let's move on. This one I did on the AB exam. Let me move this to the bottom. This one we could just differentiate both sides with using the chain rule on this side, and this -1 is a constant. And then you'll see that it's, I believe, A. Okay. This one I did on AB, average or mean value, that's 1 over the length of the interval, integral from the interval over the interval of square root of the function, square x dx. So 1 over 2 minus 0, that's the length of the interval. Integral from 0 to 2, square x dx. This one, also on the AB, this was the integral that you set up, okay? This one I need to do. This one, did I work out? I feel like I should have worked this out, but I cannot find where I did it, so let me just do it again. Okay, so we have integral from 0 to 1, x plus 1 over x squared plus 2x minus 3 dx. This one is clearly a partial fraction decomposition, okay, because it's a rational function, and I don't see a substitution that we can make. Or can we make a substitution? U is x squared plus 2x. Actually, we can maybe make a substitution. No need for partial fraction decomposition. Never mind. So good thing I'm doing this live. Okay, so partial fraction decomposition might work. I don't know right now. Probably would, because you can factor the bottom. But I see that if we let u be x squared plus 2x minus 3, du would be 2x plus 2 times dx. Or we could write it as half du is we multiply this guy by half, that would be what? It would be x plus 1 dx. So we can rewrite this integral as, let's worry about the limits later. It will be half du, because x plus 1 dx is half du, so let's pull the half out in front. Du over u. Limits of integration, when x is 0, u is negative 3. When x is 1, u is 1 plus 2, which is 3 minus 3 is 0, okay? So, oh, actually, is this the improper integral? Now that I see it, okay. So, this is just why I'm solving this live, okay? So now I notice it's actually an improper integral. So let's actually factor this guy out. Okay, this is it factored out. It's an improper integral because as we approach 1, this term would go to 0. So it'll be divided by 0. So it is an improper integral. Okay, that's fine. We can still solve it from here. It is half log of u evaluate from negative 3 to 0. So half log of 0 minus log of minus 3. This is infinite. So this is a divergent improper integral. Okay, so 36 is E. Okay, that was a good question. I did not even immediately see it was an improper integral. So you got to be careful. Okay, limit as x goes to 0, 1 minus cosine squared of 2x over x squared. How can we solve this? Well, okay, let's just plug in x is 0. We get cosine squared of 0, which is 1. So 1 minus 1 is 0. So 0 on top and then 0 squared. So that's 0 on the bottom. 0 is 0. That's indeterminate. Okay. So what can we do? Okay. Well, we possibly could do L'Hopital's rule. Let's just try it. There might be a different technique because 1 minus cosine squared is sine squared. So let me just try it since I haven't solved this beforehand. Okay, so number 37. Limit as x goes to 0, 1 minus cosine squared. Okay, let's try L'Hopital's rule. Limit as x goes to 0. Derivative of the top, derivative of 1 is just 0. Over here would be minus 2 cosine of 2x times minus sine of 2x times 2. If I did the chain rule, right? Because this is, we first did the power rule, so it'll be negative 2 cosine of 2x to the first power times the derivative of cosine, which is negative sine, times the derivative of the inside of that, which is 2. Okay? Over 2x on the bottom. Okay? So let's clean things up. Limit as x goes to 0. We can cancel this with one of those. So the top we have minus, or this would become positive. So this is plus 2 sine of 2x cosine of 2x over x. So what happens when we plug in 0 now? Top is 0 because of sine of 0 is 0. Bottom is 0. So it's still indeterminate. Okay? We could use there's an identity where sine of 2 theta is 2 sine theta cosine theta. So 2 sine 2x cosine 2x. So it'll be sine of 2 times 2x. So that's sine of 4x over x. Okay? This is actually a special trig limit. So that's probably what we kept it up there. But since we're here anyway, let's do L'Hopital's rule one more time. Limit as x goes to 0. Of 4 cosine of 4x over 1. Okay, now we plug in x is 0. We get 4 times 1, which is 4. Okay, let's hope the answer is 4. Let's see. Yes. Okay, so that's one way to do it. In BC Calc, you should know L'Hopital's rule. So that's how you do it. The other way to do it was maybe like limit as x goes to 0. We changed the top, as I said, to sine squared. Okay, then we might be able to break this up into 2 special trig limits. sine of 2x over x times sine of 2x over x. These are two special trig limits, right? It'll be, I believe it's 2 times 2, which is equal to 4, right? So that's another way to solve it. Okay. This one I solved before in the AB. This is just, if you do a substitution, you'll get the same thing, I believe. So it's 5, I believe. 38. Yes, okay. Next page. The f and g be differentiable such that we have given this table of values, basically. If h of x is f of g of x, then h prime of 1 is, okay? So here we need to do the chain rule. H prime of x is equal to f prime of g of x, g prime of x. So h prime of 1 would be f prime of g of 1, g prime of 1. So f prime was g of 1, that's 2. What's g prime of 1? That's negative 3. So it would be, what's f prime of 2? That is minus 4. Minus 4 times minus 3, that is 12. 39 is 12, yes. Area of the region enclosed by the polar curve R is 1 minus cosine theta is, okay, so I did not do this beforehand again, but this is not bad at all. Remember, area of a polar curve is, if you remember it by the area of a sector, it's like this, half r squared d theta, okay? So what is r? That's simply 1 minus cosine theta, quantity, squared, d theta. What are the limits of integration? Well, the polar curve, we can integrate from 0 to 2 pi. We'll integrate the whole thing, okay? For this one, because cosine theta, that determines one full cycle. Okay, so we can do it like this. Then let's start solving. How can we do this? Well, let's just expand this. That's probably easiest. 1 minus 2 cosine theta plus cosine squared theta d theta. Okay, so this is doable. Because these are easy, this one we have to use half angle formula, so let's break it up. So this is one integral, and then I'll do okay. I just broke up the integral because this portion is easy to solve. That's just theta half times theta minus 2 sine theta, evaluate from 0 to 2 pi. This portion, we need half angle formula, as I said. So it'll be 1/4 integral from 0 to 2 pi of 1 plus cosine of 2 theta d theta. Okay? So, okay, let's finish this side first. It'll be half 2 pi minus sine of 2 pi is 0. So that was 0 out. And then when we plug in 0, they're both 0. So that's the first term. Over here, we would get 1/4 times, here it would be theta. This guy, and if we integrate, it will be plus half sine of 2 theta. And we evaluate from 0 to 2 pi also, okay? This is just pi, this one. This one over here would be plus 1/4. When it's 2 pi, we get another 2 pi there. Sine of 4 pi is also 0, so that goes away. When we plug in 0, they're both 0, okay? So it'll be pi plus 2 pi over 4, that's pi over 2. So that looks like it's 3 pi over 2, okay? So that is C. As simple as that, okay? This one I did in the AB exam. We're asked to find an integral from -1 to 1. It's piecewise, so we had to break up from -1 to 0 of the top portion, because it's for x less than 0, and then 0 to 1 for the bottom portion, okay? This one I did it in the AB exam, trapezoid method. This would be, you have a trapezoid here, a trapezoid in here, and a trapezoid here. So area of a trapezoid is average of the bases times the height. The height is a third for all the intervals, right? So that's how you would do that. You can go look at the AB video for a worked out solution. Okay, and a few more problems. Okay. 43, we have the integral of arc sine x dx. So if you've done this before, then you know that this is integration by parts. Sorry, I'm just organizing my papers on the side here. Sorry. Okay. Integration by parts, as I was saying. So we let u be arc sine x. U is, what's the derivative of arc sine? 1 over square root 1 minus x squared dx. dv is whatever's left, that's just dx. V is equal to x. So integration by parts, uv minus v du. So uv is, that's x arc sine x minus v du. So that's integral x over square root 1 minus x squared dx. Okay? So that looks like it's e. Okay. This one, okay, this one was a tricky one. I would say it's solvable even BC now, maybe even AB. But okay, let's go through it. If f is the solution of x f prime minus f is equal to x, such that f of -1 is 1, that f of e to the -1 power is what? Okay, so we need to find the particular solution for f given this initial condition. Okay, so I worked this out before. Okay, this is what they give us. Okay, so how would we start solving this? We can't use they don't teach this again, I believe, but you can't use the characteristic equation method because there's an x in front here. So what can we do? Well, the trick here was, and it would have taken a while, even took a while for me to start seeing, if we divide both sides by x squared, so divide this side by x squared, that's just here, divide x by x squared, we get 1 over x. Okay? Why would we want to do that? Well, this looks like product rule. It's very strange, but notice that this side is the derivative of 1 over x times f of x. Okay? Or, sorry, 1 over x times f of x, or f of x divided by x. Okay? So we can use the quotient rule, which is bottom d top minus top d bottom derivative of x, just 1, over bottom squared. Okay? So I wrote that here. D by dx of 1 over x times f of x is 1 over x. Okay? So now we integrate both sides. So the integral and this derivative you would just get back this, right? So it'll be 1 over x times f of x is, integrate this, that's ln of x plus c. Okay? We can multiply this x on the other side to get f. F is x times ln x plus c. Okay? They give us the initial condition, f of -1 is 1. So let's plug in x as -1. So our y value is 1. So we plug in x as -1 here. -1 times ln of -1 plus c. ln of absolute value -1, sorry. That is just ln of 1, which is 0. Okay? And so negative c is equal to 1, or c is equal to -1. So our particular solution is x times ln of absolute value x minus 1. I just plugged it into here. Okay? So f of e to -1, we just plug that in. It'll be e to -1, ln of e to -1 minus 1. Or it's e to -1. You use properties of logs, that becomes -1 minus 1, or -2 e to -1. Okay? That's this one. Okay, so that one's a difficult one, in my opinion. And actually the key says this was not a good problem because e to -1, this thing is not in the domain or something like that. Okay, so you can ignore this problem in my opinion, but I solved it anyway. Okay. But that shook in the domain and all that. Okay, last one. Suppose g prime of x less than 0 for all x is greater than or equal to 0. And f of x is integral from 0 to x, t g prime of e to t for all x is greater than or equal to 0. Which of the following statements is false? Okay? F takes on negative values, f is continuous, f of x is, this looks something like integration by parts, I don't know. I didn't look at it carefully yet. F prime of x is this, f is increasing. Let's find f prime, because some of them looks like we want to get f prime. So f prime, what is that? That's fundamental theory of calculus, so that'll just be x g prime x, okay? So they give us that g prime of x is less than 0 for all x is greater than or equal to 0. So we're only interested in x greater than or equal to 0, okay? So since g prime is negative, x is positive, f prime is negative, okay? F prime is negative, which means that f is decreasing. Okay, so this already, it looks like will be the answer, because f prime is less than 0, which means f is decreasing. So this looks like it is the answer, but let's go through the other ones, okay? F prime is x exists for all x greater than or equal to 0. I mean greater than 0. That's true because we found what f prime is. X, that's continuous, right? G prime, it exists because it tells us this, right? So that should be fine. This one, how did they get this? Xg of x. Yeah, this is probably integration by parts, right? If it's uv minus v du. If dv is g prime, v is g. So uv minus v. Yeah, this is integration by parts. This is the formula. So this is, we can get rid of that. F is continuous for all x greater than 0. Well, we know that this is area. F is area. And we know t, that exists everywhere. G prime, it exists. So for x greater than 0, so that's fine also. Okay, so we eliminate those, and then f takes on negative values. That is true because g prime is negative, so the curve will be under the t-axis in this case, or the x-axis, whatever you want to think of it as, so the area will be negative, so that's true. So we're left with that. Okay, that's it for this video. Hope it was helpful. Please give it a like if it was, and please subscribe to the channel to look up for the next year's solutions, the next year that's released. So I don't know what it is, but look out for that video.